All right, I'll go ahead and get started. Hopefully you all can hear me. It looks like everything's going well on my end. So again, thanks for joining everyone. This is being recorded. So if you have some colleagues that aren't able to make it on time, we'll have the recording posted. So that'll be great. For those of you who don't know me, my name is Nate Spurley. I'm a technical sales engineer at RISA. Before we kind of jump into things, first, a few housekeeping items. Be aware that you can connect to the audio using your computer or calling in if you can't hear me. Hopefully that's not on my end. So I'll keep the screen open for a second just so that everyone knows we're going along. Also, please go ahead and use the Q&A chat box. Preferably the Q&A chat box, not the chat. We have other engineers sitting by ready to answer your questions. So if there's anything I skip or you're like, that's interesting, I want to know more, please shoot us a question. We'll be happy to answer those for you. So today we're going to be talking about the major new features that have been added to Adapt Builder version 22. These include the addition of ASCE 716 for wind and seismic loads, a new detailed report for minimum rebar, the ability to combine drop caps and panels for punching shear, the analysis of tendons in ramps, and my personal favorite topic, the tendon design optimization using two new tools, namely the new support line span optimizer and the update service solution button. So let's go ahead and jump into Builder. Should have a model right here ready to go. So let's review kind of this model that I have set up. I'm going to switch to multi-level mode real quick, and I'm going to turn off my finite element mesh. Let's go ahead and look at our rendered view so we can kind of see what we're working with here. So I have this ramp structure. You could say it's a parking garage, more or less. Got kind of that parking garage layout. Ramps in Builder aren't anything new, but we're going to be getting into some of the ability of adding tendons to ramps, which is new. That's going to be later on. You'll see we have, an area where the slab overhangs the ramp a little bit. We have beams, all that fun stuff. Now, I'm going to mainly focus on this level 1 area, added on this kind of addition over here for us to play around with some of the other tools. But, this, I think, showcases how, Builder can be used for not just your complicated designs, but parking garages as well, right? A lot of us go, oh, Builder's this big, powerful, crazy tool. I need it for those complicated structures. No, it can do those easy things as well, right? So I think that's important to note. Okay, I'm going to switch to single level before I forget and start doing things in multi-level mode and messing everything up. I'm going to kind of progress through this discussion, I guess, on the maybe not as ooh-ah features, kind of the more simple features, and then start working into things that are going to be a lot more fun and interesting to, progress through. So I think the first ones that we're going to go ahead and take a look at are going to be the ASCE 716, the addition of this code for wind and seismic. So just to show that that's in here, I'll go into my loading tab, open up my wind load wizard, and obviously I can pick now ASCE 716. I think that's pretty straightforward and similar for our seismic load wizard, right? We have ASCE 716. Obviously the loading is then going to be applied just based off of those codes. So again, for wind and seismic on those. So pretty straightforward there. I don't think there's too much to really talk about in that realm. So let's move on to the next topic, which is our new calculation report for minimum rebar, which is absolutely fantastic. I think this resonates with everything that RISA tries to do, in that we want to remove the black box mentality of software, right? As engineers, we want to know what the program is doing. So to show this, I'll turn on some support lines. I've gone ahead and ran this model for a bunch of load combinations. I have loading. I have some tendons in here. It's missing some things, so we're going to go ahead and start adding those. We'll get into that. But for the new minimum rebar calculations. If I double click on a support line, a lot of you are probably familiar with this section cut detail, if you will. So I can kind of, mouse wheel and see the section cut highlight as I'm going through this. For example, this cut, we can see that the controlling rebar is due to service total, and we have 1.3 square inches. Nothing new there, but what is new and absolutely fantastic is if we click on this calculation report button here, it'll generate an Excel report for us. We'll go ahead and open this up. All of the data in here more or less just showcases what we saw on that previous screen in the support line window, right? We have kind of the general information that this is a two-way. We're using ACI 2019, unbonded system, right? We have kind of our materials, our preferred reinforcement, section geometry, right? Kind of all of the typical parameters, our moments, all that fun stuff, and then that calculation as well. What I love about this new report is there's actually this AS min tab. And in here, we actually dive into all of the calculations that are going on behind the scenes to calculate minimum rebar requirements. Not only that, it's actually referencing the code. So for those of you who are familiar with the RISA program, specifically like RISA 3D, that detailed report option, I love that tool because someone like me who's only really done post-tension concrete design when I was doing design work several years ago, and I pick up RISA 3D and try and do steel, and I dust off my steel manual. The detail reports are a lifesaver, right? I can dive into the code, I can figure out what the program is doing and really see what's happening. Notice that it's also doing it for each load combination that I have analyzed. Obviously, this is just minimum rebar at this time. We're going to be adding onto this, of course. Right now, we're working on a one-way shear report, so that's going to be great. Another key point to notice here, right? It's showing not only the equation and the values and kind of a description, but the equations for the calculations actually get updated depending on what controls. So in this situation, just based off of the cross-sectional geometry, this is how we're getting our minimum reinforcement for this section. If stress is actually required, according to ACI, if we started to exceed that 2 square root F prime C tensile stress, this would update and show that we were using that equation and the value that we got for it. So again, trying to remove that black box feeling that a lot of softwares have and making Builder just that much more transparent in what's going on. So awesome. We'll set that aside and let's go into our next topic, punching shear. That's always a fun one. I remember doing designs in Builder several years ago when the punching shear didn't even envelope and it didn't have a graphical view, and it was just very painful. Now it's so much better. So let me go ahead and turn off my support lines. I actually haven't ran a punching shear real quick, so we'll jump into floor design. We'll execute the shear check. It just takes a couple seconds. Let's jump into our strength combination. I'll look at my dead and live because that's probably what's going to control. And we'll take a look at our punching shear in this situation. Right, so I have these two columns here. This one was failing before I added the drop cap. Both of these have a drop cap of 4 feet by 4 feet square, 18 inches deep. So this one wasn't okay until I added a drop cap. This one is obviously still having some problems. That's the power of me doing some prep, adding a bunch of loading over this column and making it fail. The reason I did this is so that I can show you the new improvement, which is you can now place a drop cap within a drop panel. So if we go ahead and jump into the model tab, I can then click on drop panel. It's the same drop panel, drop cap. Really, you specify the difference within the type here. So obviously these two are specified as a drop cap. And now I'm going to draw on a drop panel. This one is 8 feet square, 12 inches thick. So I'll just drop that guy on there. Let's go ahead and reanalyze this real quick. I'll do it just for my service, or not my service, my strength dead and live, since that one's probably controlling. And while this is analyzing, it's important to note that Builder always takes into account drop caps and drop panels, regardless of their shape. I know there are some restrictions with code based off of sizes. So pay attention to that. If you have a very small drop cap or drop panel, Builder is still going to consider it for your shear and flexure. So That's worth noting. Perfect. So once that is done, we can go ahead and run a punching shear check, which again takes 2 seconds. Now, if I didn't iterate or mention this enough, or beat this dead horse, you need to have a drop panel, then the drop cap, then the column. Can't do the other way around. It can't be cap, panel, column. Again, it's panel, cap, column if you're getting into these. Okay, so now that I've done that, we're still on strength dead and live. That's the only one we did. Obviously, our stress check is now okay. Great. How do we know that the program is checking this correctly? If I actually click on the condition, you can see kind of the dotted lines for the critical section that the program is taking at each of the slab transitions and even the effective depths that the program is using, right? And obviously, I think we have an 8-inch slab here. Yep, we have an 8-inch slab. Obviously, then the 12-inch thick panel, 18-inch drop cap, and that's kind of where we're getting those effective depths. And if we look at this one, right, similarly, we just don't have that 12-inch panel for that effective depth. Awesome. Okay. I think that kind of covers the more basic new features, if you will. I think they're fantastic. They're going to help a ton in your designs. But I think the next topics are really where I'm excited to get into these. So let's go ahead and start adding some tendons in ramps, which is now possible within Builder. So I'm going to go ahead and turn off my finite elements there. Let's turn on my tendons real quick, just so we can take a look at what we have. So right now I have some banded and distributed tendons. Obviously, I'm missing my distributed in this area, and we're missing tendons in the ramp. So if I go ahead and click on an ISO view here, right, we're missing tendons in this ramp. I do have some tendons kind of in the beams running alongside the ramp, but we're missing them in the ramp itself. For those of you who have not actually modeled ramps in Builder yet, it's actually pretty easy. You jump into the model tab and you click ramp, you pick the 4 corners and you go. If your ramp's oriented the wrong way, you can go ahead and just flip it. Pretty straightforward and easy. When you start adding in beams, which it gets a little bit more complicated, it's really not hard to get those connected. You simply select connect with ramp, and you can do this with your loading as well as your beams, as I said. Tendons, it's actually easier. You would expect it to be a little bit more difficult, at least I did, and then started using the tool and I was like, oh, this is really, really easy. So let's go ahead and jump into it. So I'll go into my tendon tab and let's go and add a tendon. I'm going to do in the distributed direction first. We're going to have 2 strands. That looks good. And it's as easy as zooming in here. Now my ramp, before I kind of start modeling, isn't fully all the way to the slab edge. I didn't model the slab kind of around the ramp. So I need to be careful that my tendons aren't falling outside of the ramp when I model them in this case. But that's just based off of how I set up my geometry. With these beams, I simply need to model my tendon along the center line of the beam. And so using some of my snap tools and just kind of going along the beam, it's as easy as that. Now, if I exit this and I double click, we're not quite in the ramp yet. We can see the ramp, which is great, but the tendon is not in the ramp. Well, that's an easy fix. All we simply need to do is click the checkbox, connect to ramp. And it is literally that easy. If I double click the tendon, we're now within the ramp. Piece of cake, not a challenge at all. Okay, let's go ahead and add another tendon. Thankfully, Builder keeps the previous input that I used. I don't know if I was to the center line of that beam. Let's make sure we're at the center line. Okay, that's great. There we go. Do one more there. One more there. Of course, I'll select this tendon. Yep, checkbox is good. I'll double click just to verify. That looks great. I could also go into my rendered view. We'll take a look at the rendered view once we add in all the tendons. Now, I could copy this tendon down and kind of go this way, but all of the CGS are based off of the beam right now, and I don't want to adjust all of them. So I'm just going to draw another tendon, which honestly takes 2 seconds. So I'll just go from there to there to there. And you'll notice I actually snapped kind of to the end of this strand. I'm using effective force. So what's nice is when I copy or well, I already have the tendons copied, but if I wanted to copy these tendons up to the other ramps, since they're effective force, and I have probably tendons running from, the top of the ramp all the way down and through to the bottom with effective force, the lengths really don't matter that much. The force is still being put into the slab, which is fantastic, right? Okay, let's double check that this tendon looks good. Great, we got profile, I love it. Let's go ahead and just do, the old-fashioned way of copying this guy down. I think I need to offset him in the Y direction 4.5 feet, and we need 2 more. Great, so we'll copy that. And we got some tendons in the distributed direction of our ramp. Now I'm going to do the banded direction, but I'm just going to do kind of a distributed in both. So it's as easy as doing the same idea. We'll just go ahead, go in here, add a tendon. I don't want this to be the distributed. I'm going to define it as banded. And we'll just draw it from there to there. Piece of cake. I'll actually do this one at the same time because it's just 2 more clicks. Great. Let's double click on those and make sure everything looks great. Awesome. Now, I want evenly spaced tendons, and I don't really have good snap points like I did in this area, so I'm actually going to copy this one. So we'll go ahead and modify it. We'll copy by coordinates. This one we're going to put in the X direction, -4 feet. So we'll copy that, and let's go ahead and adjust the CGS for this one. If you look carefully, you'll be able to see, right, it's kind of referencing the beams with that 10 inches. I don't want that. My ramp is 8 inches thick. So I'm going to go ahead and set that to 4. And as I zoom in there, you can kind of see the reverse parabolic shape that we have for that tendon. Great. Now that we have that one, let's just copy it, rinse and repeat. We'll go in the X direction, -4 feet. And I think I can fit 4 more in there. Yes. Okay. Awesome. So instead of doing that again and again and again, I'm just going to grab these, and then I'm going to duplicate my selection based off of this reference point and just drop the tendons in like that. And we're going to put some there too. And just like that, we have tendons in ramps. So if I go ahead and switch to a rendered view, I could go ahead and copy these tendons up. Well, it's kind of hard to see. Let me go into a shaded view. There we go. All right, you can see all those tendons in there, drapes and everything, all mapped to that ramp simply by clicking that checkbox and drawing the tendons in there. I could, again, grab these and copy them up. I already have them on this ramp. You might be asking, well, why don't I see them? Well, we're in single level mode, right? And in single level mode, Builder only considers the one slab that we're on and the ramp below. If I wanted to consider the ramp above, I would then need to start looking at multi-level mode. Okay. So before I kind of prove that these are not just shown there and they're actually being analyzed, let's go ahead and add some tendons in this area for the sake of time so that I don't have to analyze and design again and again and again. So I'm going to go ahead and use my smart tools. Let's be honest, the only reason I'm doing this is because I love using the smart tools. If I get a chance to use it at any moment, I'm going to take advantage of that. For those of you who haven't seen this, it's super easy to add tendons. So I'm just going to add in some distributed tendons at about 4.5 feet from there. Oh, from there to there. There we go. Let me make sure. Yeah, I was doing 2. Okay, perfect. So we have some preliminary tendons kind of in this area. Obviously, I didn't really do any design for this. I just kind of picked some with some spacing, added some tendons in my ramps. Now, I'm going to go ahead and analyze this. Now, while I analyze this, I ask all of you to do one thing for me, and that's pay attention to the analysis time for this and also the design. So I'm going to analyze and I'm going to design. So obviously, this is a pretty light model, but the reason I want you to pay attention to the analysis and design is one of the new tools, well, actually, both of the new tools regarding tendon design have greatly increased the speed at which you go through kind of that iterative process when it comes to tendon designs, right? For those of us who have been doing PT designs, we know that once we kind of get to this point, trying to resolve stresses, pre-compression, and all that fun stuff can take a long, long time. So there's the analysis. Only done the analysis, so that's only part of the story. Let's go ahead and do the design. All right, so we're getting through the design, and I did it for the 3 service combinations. I did service total, sustained, and I guess my initial. Right, so this shouldn't take too much longer. I swear getting on a Zoom call really slows down the builder analysis times, but not too bad. Okay, so maybe you can reminisce on how much I rambled when we get to the next part of how speedy this stuff is. So I could go ahead, back to ramps, I could go ahead and check my deflection. For those of you who didn't know, there is a view analysis results viewer. I don't use this all that often because, well, I just like the pretty deflection side of things. But in here, what's nice is this actually shows the analytical model. So if I go ahead and turn on my tendons, these aren't just the physical tendons as we modeled them. These are actually analytical tendons as the program is recognizing them, which, no surprise, builders have been able to do, you know, 1-way and 2-way slab design for years and years and years. If I go ahead and turn on my shaded display here, we can actually see these analytical tendons within the ramp now, which is great. And you can actually see kind of all of our elements, our finite elements, and all that good stuff. Again, we're not seeing the tendons in this ramp because we're in single level mode, but they are there. Okay, great. So that's tendons and ramps. Obviously, this is analysis only at this point. That's the first step towards design. Design will be coming. Not exactly sure when that's happening, but we are working diligently on it. Very excited to offer, you know, the ability to do that because, well, I don't think many can. In fact, I don't know if any can. So that'll be very exciting once that's here. Okay, let us go ahead and dive into the new tendon design tools. Like I said in kind of the intro, this is my favorite part of the new release. So again, remembering how we would go through the design of a post-tension slab, right? We go ahead, we analyze, we design, we jump into our design sections, and we look at our stresses, for example. And okay, looks like I'm passing top stresses in both directions. Let me turn off my tendons for the time being. Right, we're passing stresses in both directions here, which is always a good thing, at least in this case, right? We got top stresses in the Y, we got top stresses in the X. That's great. But bottom stresses, on the other hand, we have some issues. This direction is actually okay, and this direction is where we're seeing some problems. Right, so some bottom stresses kind of along this span, but furthermore, we also have some pre-compression issues, right? Which I was lucky in picking my tendon spacing, you know, at that 4.5 feet with 2 strands. I obviously didn't meet pre-compression, and I have some bottom stresses in that area. Let's go ahead and check the other direction. This direction's okay. So everything's kind of limited to this Y direction. Now, in the past, it'd be pre-compression is typically easy to resolve. You break out your calculator, figure out the tributary width, start doing some simple math to figure out, okay, how many tendons do I need roughly to get a pre-compression? That's not a hard calculation. The harder calculation, or should I say educated guesswork, is resolving stresses top and bottom, right? That gets a lot more complicated. Well, let's focus on the easy stuff first, and then we'll move into the more difficult aspects of things. So the new tools that we've added, I'll start with the first one, is the support line span optimizer tool. So that's under the tendon ribbon. When I select this tool, if you pay attention to the support lines, which you have to have turned on before you start this tool, because when you turn the tool on, you'll notice there's kind of these symbols that get added to each support line. And you need to select those symbols, box select those symbols in order to start using this tool. In this case, I have my minimum and maximum values being shown. I don't have values for every section cut being shown. So I know that this pre-compression right here is actually my minimum. So I'm going to go ahead and box select this. And instantly you'll notice the program adds, well, or should I say highlights, probably the 3 most critical sections. There's critical section A, B, and C. Obviously A and C kind of being where we're going to expect our top stresses, and B, where we're going to expect our bottom stresses, right? I went ahead and picked this span because I have my minimum here, and that's an important note. The optimizer right now is doing things on a per span basis. So if this is my controlling span, I'm obviously going to use the optimizer for this span. Okay, great. So once I have selected my support line, the optimizer updates. Now we have kind of this blue line showing the range for our top and bottom stresses per code, the range of our pre-compression and load balancing. These are all just kind of set up in our settings tab, right? You can kind of pick a minimum and maximum as needed. And then the red line is kind of showing us where we're at within this span. And then the green line is where we would be by implementing the proposed changes. You can actually see the program saying, hey, you need a minimum of 9 strands, but you're only providing 6. Okay, great. Well, let's go ahead and actually start implementing these changes. Now, it just so happens to be that this section cut is occurring at my lowest pre-compression point. If it wasn't, I could go ahead and jump into the settings and change and move these sections as needed. Furthermore, I can actually jump into the details of each section, A, B, and C if I wanted to. So in this case, we're looking at section B, so I'll switch to it. And we can see, right, with a little bit of rounding, program is seeing -55 for pre-compression. Now, for those of you who have used PTRC in the past, you might be getting, antsy in your seats because this, in my opinion, mimics PTRC a lot. It makes tendon design and optimization super, super streamlined and easy like PTRC. And that was the goal with this, right? So with that, I'm going to go ahead and just apply these changes. Now, if I wanted to, I could switch to a different load combination. In this case, service totals, the one that's going to be controlling, but I can kind of shift between them if I have a bunch of different service combinations. So back in the force tab, we're going to go ahead and apply these changes. Now, before I do, you'll actually see some blue text, which I totally skipped over. This blue text is actually flagging the tendons that are going through this strip. So if I turn on my banded tendons, not banded, distributed, that's our distributed direction, you can see the program has picked up these 3 groups, if you will, for the tendons that are passing through this strip. And they're actually labeled. So this one is group 1, it shows 1S, that one's 2S, and my text overlap there due to the support line is kind of making it hard to see, but that is 3S. And it shows the number of strands in each group. Awesome. So in this case, we have 6. I'm going to be adding 3. I like that because it's round numbers. So I can just click apply. And in this case, we're seeing a total required change of 3 strands and 1 per group. Great. I'll just click apply and get that updated. We'll see our graph update, and the tendon color actually changes because our service solution is no longer up to date. I could go ahead and click the update service solution, and that would update the results for the support line based off of the tendon changes I've made. And it will do it significantly quicker than doing the old-fashioned way of going analyze and design. Now, I could do that right now, but we obviously have some other issues in this model. So let's address those at the same time rather than running the analysis and design 4 or 5 times for each section. So I can simply leave this tool open, go over to, let's find our next minimum pre-compression. There it is. Right, so we're seeing about 100 PSI of pre-compression here. So that one's controlling. I simply box select it. In this case, that section actually isn't occurring at the minimum. If we jump into the stress details here, and I update this, right, we're seeing about -102. I doubt the 2 PSI of pre-compression is really going to change how many proposed tendons we need, but let's go ahead and update it just to prove a point. So in this case, I need to move section B over to the critical location. So I can jump into my settings, say section B, I need you to move over 2 sections. Oh, I missed it. We went 1 too far. We need to go right there. Piece of cake. So now back in the force tab, seeing the envelope solution, right? Everything is kind of optimizing based off of the mins and maxes in this case, right? Our stresses were very well okay already. It's more a pre-compression. So in this case, we're seeing a total of 4 tendons, but we're adding 2. Now I could deselect some. I'll show you how to do that here in a second, but I actually am just going to add 1 strand to each of these, partly because I want to work with even numbers and also because I don't want to try and optimize this drop cap. I'm just going to add in an extra 2 strands in here, maybe over design it a little bit. And so all I need to do is just say, let's increase that to 12. And the force updates. And you'll notice we actually get a no good on load balancing, which isn't really a problem for me in ACI. In fact, it shows at the bottom, there's this message, hey, the user-defined allowable limit is not met, i.e. my load balancing, but this is not governed by the design code. So if I'm okay with this, I can go with it. If I actually want to ignore load balancing entirely, I can just uncheck it. And then it doesn't pay attention. And then it would potentially update my proposed design with without considering load balancing. In this case, since I forced it, we'll just go with that. I'll click apply. Again, I have a total of 4 groups with a total of 4 strands being added. So I'll go ahead and click apply. Piece of cake. So tendon color changes. We now have additional strands in that area. And that should hopefully take care of that slight little lack of pre-compression in that drop cap. Something to note is though I'm only looking at this one span and I'm applying tendon changes, those tendon changes are being applied over the entire length of the tendon. So even though I have some pre-compression issues over here, I have gone ahead and added 4 additional strands in this strip, and that applies to all spans, which can somewhat be problematic, and I'll show you why here in a second. So let's take a look at the more complicated situation where we have some bottom stresses, right? This is where we would potentially start iterating over and over and over again. And if you're like me, being a bad guesser when it comes to PT, sometimes that can be several analysis and design iterations later. So in this case, again, our maximum bottom stress is being displayed, but we do have some bottom stress over here. So with this span being the one that's controlling, I'll go ahead and box select it, get that symbol selected, get that updated. Again, our section cut just so happens to not be in the correct location. That's an easy fix. So I'll move that over. And now kind of the force diagram is optimizing based off of the critical stresses. Great. Again, I could jump into the details of these if I wanted to. All right, take a look at section B. We can see, right, we're at a bottom stress of 394. And once we apply the proposed changes, we're going to be closer to 192, which is pretty great. So in this case, you can see the program is saying we need to just add an additional from 12 to 16. That's 4 tendons. But I have a total of, if we look at that one, six groups. Well, I don't want to add too much PT in this, so I'll go ahead and do that. So when I click apply to model, it's saying we need a change per tendon of 0.67. I don't like fractions. I'm not going to deal with that. We're adding 4 tendons. So instead, I'm going to add them in. We have a thicker slab up here. So I'm going to say, you know what, let's add these 4 tendons not to the first and second group. So I can simply just deselect those. And we'll see the change per tendon update, which is great. So we click apply. And then we'll see those colors update for the tendons that actually changed, right? We deselected those 2, so they don't see a change. Okay. So we've gone ahead and applied these tendon changes. If I had issues in the Y direction, I'd turn on my Y direction support lines, apply the changes as well, kind of using the optimizer. Takes a lot of the guesswork out of how many tendons do I actually need in this area to mitigate stresses, dead load balancing, pre-compression, all of that. And once you're done, you can click the update service solution. Now, by default, the program is only looking at the one support line. I made changes to several of them. So if we jump into the settings tab, I'm actually going to say, hey, I want to design all the support lines. Okay. I'm going to click update service solution, and then I'm going to pick my load combinations that I want to update my service solution for. Now, This is where I need you to reminisce or recall roughly how long it took to run through the analysis and the design. So I'm going to run the same combinations that I did the first time. So we're going through them. This is going to do the analysis and the design for the same 3 load combinations we originally did. And honestly, it's going to do it significantly faster. Again, this is a lighter model, so you may not see that much of a time difference. When you start getting into your heftier models, you're going to see that. So literally, I've already made it through the analysis and there's the design, right? So this is going to save a bunch of time when you start getting into the tendon iterations, right? Which is great. So if we go ahead and click OK, let's close out of this tool now, and you can see we have now satisfied our top, our bottom, and our pre-compression. Yeah, the simple calculation isn't being satisfied. That's okay. I'll go with these and assume that is great, right? And I did that in one iteration rather than trying to guess how many tendons I actually needed to do to fix that bottom stress here. Fantastic. Now, I did ignore one part of this, and that was load balancing, and I did that on purpose. All right, so if I go ahead and turn on my load balancing, for example, you can see we have several areas with load balancing issues in here, primarily where we had those bottom stresses and we had all those tendons. Well, okay, how do we fix this? Well, in the support line span optimizer, we only had the ability to add, or technically it could remove tendons too. If you over design something, it'll reduce the number of tendons. But that's it. It's not making any tendon profile changes, which tendon profile changes really can impact your load balancing, right? So how do we go about that? Well, again, in the past, you'd go through here, maybe use your smart tools and update your CGSs and then run through the analysis and design again. You don't have to do that anymore. Using the new service solution update button, you can make tendon changes, any tendon changes you want, and this will run through more or less the same operation that we ran through with the update service solution. Now, let me emphasize, this only works when doing tendon changes. If for whatever reason you add loading, change geometry, something gets added, other than tendons, you would have to run through the analysis and design. If you are only doing tendon changes, which, let's be honest, you get to a point where you're running through these iterations, that's where you can use this option. So, for example, let's go ahead and jump into our smart tools. I'm going to edit some of my CGSs. Now, I do have some crazy balancing in this location, which I don't think I'm going to necessarily be able to fix unless I start adjusting the beam tendons in here, which I have quite a few kind of going through that ramp. But in these other areas, let's just raise the CGS from 1 to 2. So, using our awesome tools here to influence the, oh, I didn't want to do my tops. That's the wrong one. So I'll undo that. Let's go ahead and change all of these to 2. That's great. Change those to 2 as well, and these to 2 as well. So we're just a little over our dead load balancing. Great. Okay. So I've made those changes. And again, instead of running through analysis and design, since I only made tendon changes, I can use the update button. And sure, let's do it for all 3 load combinations. It's so quick anyways. Why not do it, right? Normally in the past, I'd find that one combination that was controlling, so I didn't have to sit here and watch the analysis and design, but it's so quick, I can do that now. So once this is done, hopefully we have resolved not only dead load balancing, but also our bottom stresses. Now, close, still some issues in here. If you recall, that was 115%. I only increased our CGS by 1 inch. Maybe I need to do that a little bit more. Obviously, this area was at 140 due to those beam tendons. I messed up the drape there. I could go ahead and fix that, but now we can see our dead load balancing is good. And not only that, but we're still satisfying the bottom stresses in this location, which is absolutely fantastic, right? So once you've gone through the iteration, added your tendons, and you are satisfied with, the tendon layout and your pre-compression stresses and all that fun stuff. I'm not going to say you should. I'm going to say it's more or less mandatory to then run through another full-blown analysis, including your strength combinations, because you have now changed your tendons. And then that way, when you go into floor design and generating rebar, you have an update solution for your new tendon layout. Because recall, these buttons are only focused on the service solution. So once you've made tendon changes and everything's good, run through an analysis, get your design, and obviously generate your reports and be happy that you did your job in half the time due to these new tools. So I think that about wraps it up. Let me get back to our screen here. I think that about wraps it up for the new features that are in Builder version 22. I appreciate everyone's time and attention during the webinar. If you're wanting to learn more, obviously we have the resources on screen. We just added this awesome new video repository on our website. If you haven't checked it out, go there now. It's got awesome searchability. I absolutely love it. It's www.risa.com/videos. You can also email us at info@risa.com. If you have any questions that you don't want to answer here, you can ask them there and we'll answer them. And so I'll leave the meeting open for a while longer in case there's any questions that you do want to ask. Thank you all for joining and happy holidays. Ben, are there any general questions that I can answer for the group?
Yeah, thanks, Nate. Yeah, we do have a few. So the first question that came in, basically someone asked the question along the lines of, hey, this has been great for a new release, basic information, but what if I need to learn or want to learn more about some of these features? You mentioned videos, but do we have any other training options, or are there any training options for people who want to learn a little bit more about Builder?
Yeah, definitely. So that's a great question. So if you don't own Builder at this point in time, you can always schedule a software tour with us. There's a couple of links on our website. So for those of you who are like, yeah, I'm still on the fence about Builder, or I am, how can Builder help me in this project? You can schedule a software tour. Myself or one of my colleagues is happy to walk you through, how that can help you on your next project. And we also have trials on our website. So if you want to test out the software, behind the scenes, you can go ahead and do that. That's as simple as, if you do have an account with us, you log into your account, go to the downloads tab and click the try now. And then the last option that we have is we do online trainings. So if you go to our website, there is a learn tab, and I think the training option is under there. We do Builder trainings. I think right now we're doing about every other month or every third month. We have a basics course and an advanced course as well. So those are all great options. So great question.
Cool. Yeah, we got another question about column design. So the question was focused on how to transfer loads to other softwares for column design, but I think that obviously we've got some new stuff coming up in Builder. So do you want to talk a little bit about that?
Yeah. So very, very exciting. In the past, we didn't have column and wall design. We currently, we have wall design, right? We have ACI, I think it's 2011, but we are working very diligently on having concrete column and wall design native to Builder. So no add-on feature or whatnot. So if you have Builder, keep an eye out for that. That will be coming here very, very soon. Not exactly sure when that's happening, but fingers crossed it's next year, and that's where everything's at. So yeah, another great question. Any others?
Let's see. It doesn't look like there are any other questions here nothing so far. So I guess like Nate mentioned, we can leave the presentation open for a few minutes. If you want to ask a question in the Q&A, obviously we can answer those live, or we can go ahead and answer them in the chat. But yeah, it looks like right now we've kind of filled out. So again, like Nate said, we appreciate you joining us, and reach out to us if you're interested in Builder. Get a software tour with Nate, or take a trial to check out some of the new features, or just reach out to David and Shauna and the team in support and get some questions answered. All of those are great avenues to see exactly what's going on with Builder. And we're really excited about all of the stuff that's coming in the new year. So I think we can probably end there. So thank you, Nate. Great presentation. And thank you, everybody, for joining us.
Thanks, everyone. Happy holidays.